Okay, this is section 1.3. And what we do now, we're going to, it says it's called something like making new functions out of old functions. So the old functions is the set of essential functions from 1, 2, and specifically the graphical parts of those. So what I'm going to do, I'll just put 1, 3 here. So we're going to make this statement. Given a function f, so this f of x will be the so-called old function, and this will be one of the essential functions. We create a new function. I'm going to call it capital G for emphasis. And what I'm going to do, I'm going to have a column here, how we're creating the new function from the old one. And then I'll have an example and I'll show the graphical result. So the first thing I want to do is take an old function, one of the essentials, and I'm going to add a constant. If you had trigonometry at Penn State, Math 26, you go through this thing similar to this with this A, B, C, D. This is a generalized version of that. This is doing that, but it works for any function. One thing I should add up here, given this statement, is that C will be a constant, some value, some number. And this is what we call, this is a transformation. Okay, so the example I want to do, and I think I'll use the same old function, the same essential function for all of these. I think I'm going to use the root function. So I'm going to say, it's called g of x still, is going to be the old function plus, might pick whatever I want, 2. So what kind of a transformation is this? This is what we call a vertical shift. And specifically, this is up C units. So for this example, I'm taking the old square root function, starts at the origin, tails off. That whole thing is going to be shifted up 2. So I'm going to start up 2 units and have the same shape. And of course, if this happened to be root x minus 2, well, what does that mean? If I move up -2 units, that's moving down. Okay? So a shift. The next one is a scaling. I want to write it this way, g of x equals, and now I'm going to take the old function, the old essential function, and I'm going to multiply it by some value. And what this is going to be a vertical, and I don't know what the best word, for lack of a better word, stretch. And it's important to know, let me add this, that's when C is greater than 1. So this is the first one, this is the second one. So again, I'll use 2. So this will be 2 square root of x. Taking the old essential function, multiplying it by a factor of 2, and this So again, the original now, this one is rooted at the origin, but instead of the old one, say, looks like this is going to stretch the whole thing up. So when I say C greater than 1, it's a stretch when it's greater than 1. It's a compression, which is the opposite of a stretch, if C is less than 1. So in other words, if this was a half instead of 2, I'd be pushed down by a scale factor of 2. So this is a shift, and this is what you call scaling, affecting the scale. And keep it, notice the origin remains the anchor here. So it's like the origin is anchored. We're grabbing the original and we're stretching it by a factor of 2. Okay? What else can I do? I can negate an essential function. For example, g of x equals negative square root of x. And what this is a vertical reflection. So this in other words, we're reflecting over the x-axis. Right, we're going to reflect this way. So if I reflect the square root function over the x-axis, again, this is the anchor point, you could say, it'll look like this. Okay, so those are the first 3. I have 3 other ones, and they're grouped this way for a reason. Notice the first 3, everything happened vertically. We shifted up, down, we stretched or compressed up, down, and here we flipped up, down. Now we're going to do the same 3 types of things, but horizontally. So again, I'll use the root function. So don't let this get confusing. This is f of x minus c. And what is it? Notice the difference. You say, well, that looks the same. Well, in this case, I want to point this out right away. So this would be an example using the root. Now notice the difference. When you vertically speaking, you are adding to the original function. This is a function plus 2. When you're working horizontally, you're affecting the variable. So this is square root of x minus 2 or x plus 2. So this is a horizontal shift. And this is c to the right, c units. Now let me graph this and say something that's sometimes a source of confusion. So again, I take the original, which maybe I'll put in dotted, right? And I'm going to move it over 2 units. So it's a translation. Okay. Notice this can be a source of confusion. This says x minus c. So x minus 2 is 2 to the right. It's counterintuitive, I guess you'd say. So if this said x plus 2, well, x plus 2 is x minus minus 2. So if it's plus, you go the other way. So minus a value is right, plus a value is left. So we had a vertical stretch where again, a scale factor applied to a function. Well, what if I apply a scale factor to the variable itself? And again, let's put an example down. So this won't be 2 times the old function. this will be square root of 2 times the variable. The effect is going on the variable. Okay, and again, this will be a horizontal scaling. Let's put that. And again, we have this is the opposite. This is a compression for c greater than 1. And this is a stretch. Stretch. How do you spell that? C less than 1, which is the opposite of the vertical effect. So this will be, and again, you notice I'm not putting a lot of numerical information. This is more about qualitative. I did with the shifts because that's really easy, but I'm not trying to, like, the scaling, I'm not trying to get points down here. We understand it's more about the physical effect instead of the numbers. So this is a compression. The factor is by 2. So again, if the original looks like this, what does it look like when I compress horizontally? It kind of gets scrunched up here, something like that. Okay? And we had a vertical reflection up and down this way over the x-axis. Likewise, we can have a horizontal reflection over the y-axis. So g of x equals, and now we negate the variable instead of the original. So example, so this will be a horizontal reflection. And again, that's over now the y-axis. So let's look at this. I know what you're thinking. You see that and you say, oh, I thought you can't put a negative under a root. You can't. But what if x is negative 2? Well, negative of negative 2 makes it positive. So this will be a horizontal reflection. Again, the original going that way, this new one going that way. So those are the 6 transformations. What we like to do, and you'll see in some of the homework, we can apply multiple transformations to a function. So when I do these, I typically do them in, like, well, you'll see. So some examples. So it's really, this is just, we're going to make a sketch. We're not going to put a lot of points down with numbers. Again, we're not interested in XY coordinates so much. So what we need to do, it's kind of a 2-step process. So let me there. I'm going to use Y just because it seems like that's what the book does in the exercises. X plus 1 cubed plus 2. So job number 1 is to identify the so-called old function or the essential function. And don't overthink it, right? There's a cube there. The cubic is the essential function, the old function. So what I'll do as I do this, make a nice big pair of axes here, is I'm going to just come in and do this dotted. You don't necessarily have to do this. If it's a mental exercise, you're comfortable with it, that's fine. Things should revolve around the anchor or the origin. That's the anchor point of this. So the first thing I notice is here, x plus 1 cubed. Okay, well, what was that? That was a shift horizontally. And again, if it's minus, it's right. If it's plus, it's left. So this is a shift 1 unit to the left. So I'll even put the 1 there. So again, that's just one of the, it looks like there's two transformations. So I come in here and I do that. Well, now I have that curve, and I'm going to add 2. That's now the vertical shift. That's going to be up 2 units. So if this is 1 and 2, this is my new origin. I've shifted and I've shifted. And I do the best I can to put the shape in. Now, if you had said, well, what if I think, all right, it's a cubic, and then I go up 2 and then left? Well, it's okay. It's the same thing. Okay, so what is the original? What's the old function? The old function appears to be the root function. So we know that looks like that. So the first thing I see is that I'm negating the original. Okay, what does that do? Well, that was a vertical reflection. So that would put me here. And then what am I doing on this one? I'm going to be vertically shifting now down 1 unit. So again, the origin is your center, your anchor. So that origin moves there, and I move this curve down here. So that's Y. All right. Sometimes they try to throw you off a little bit. For example, this is a... Oh, that's strange. I guess it's not. So this is, I guess you could say, written sort of out of order from the presentation, right? There's nothing here that says C plus f of x. But addition has no order, so they play these little games to kind of get you confused, but that's no different than that, which is exactly this. So this is just the reciprocal function, which was one of our essentials. Looks like this. And that's all shifted up 1 unit. So we didn't have a lot of conversation about asymptotes, which is fine because that's all coming. These, with the original, with this guy, these axes are what we call asymptotes. So what I'm doing here, we'll get to this in more depth later, so don't get hung up on it. I'm moving that asymptote up 1 unit. Well, I'm moving this one up, but it's vertical, so there's no change. And this would look like that. It's a little bit messy, but that's the idea. This is why. Interesting. So let me do one more. Again, somewhat out of order. I mean, it's not a big deal. I'll write it like this. Okay, so the essential function in play here is the cubic. So what I'll do, I'll put that in, and again, if you're comfortable just doing this mentally, that's fine. So the first thing I'm doing is negating the function. Well, that's different than, say, this, which is negating the variable, right? So that's going to flip it over the x-axis. So this one's, it's like this is a wire it's being spun around on. And then I'm going to shift up 1 unit. So this, make sure you do the right one. So this is at 1, and this should look like that. Okay? Let me pause here for a second. Okay, I said do something quick. Okay, so those are transformations. I didn't even really title this at the beginning. It's not the title that the book uses. That's why. Transformations. Manipulations, if you like. Okay, so again, just to reiterate what we're trying to do, we know these essential functions, we know what the graphs look like, and now this opens up a lot more that we can graph easily. Okay, so combining functions. This is more of a, well, the first part of it is more just about notation than anything. The end is very important. Functions. So given, we're going to have two functions. F and G. We're going to create, so what I'll do the same thing. This is what I'm defining. This is my example. So for the examples, let's say F is something simple like x squared and G is something simple like x cubed. Now here we're not interested in graphing this with this stuff. This is just pen and paper, algebraic. Okay, so the graphing stuff we put aside. The new functions, and the reason we do this and the reason I say it's notational is because this stuff looks kind of strange. The new function is this, written this way, which we don't see a lot of. And what is this? Well, it's exactly what you would probably guess, and we're just going to add them together. So if these are my two originals, well, this weird looking function f plus g of x is the sum of these two. And of course those don't combine. And what we do is we just go through the four operations. So we have subtraction, which is exactly what you would think it is. And again, with this pair, this would be, now the order matters here because it's subtraction. This would be x squared minus x cubed. Whoop, I said it and didn't write it. Okay. Multiplication. What do you get? What is, if you see this bizarre looking thing, what does it really mean? It just means what you would think it would mean. F times G. So in this case, this would be x squared times x cubed. Now these do combine. So we should do that. Call that x to the fifth. And lastly, but not leastly, division. Again, no surprise here. So given these examples, if you saw this, that would be x squared over x cubed. And again, we should cancel here. We should simplify this. This is 1 over x. Reality is you're not going to see a whole lot of this, but you are going to see a whole lot of what's next. And it's a much different way to combine functions that we call composition. Composition of functions. Ugh. Okay, so again, we'll do it with two. So given two functions, call them f and g again. And I have to make this point. The book will use two different notations. In the exercises, I believe they show it this way. F compose G of X. It's not my preferred way because it doesn't really show you anything. It looks like it says fog. But what does this mean? It means I feel better written f of g of x, which is what you would get if you put g in as the input into f. And I just make this point that if composed the other way, g of f of x, which would be the opposite, these are oftentimes different. In fact, if they're the same, that's an indication of something that you'll learn about much later. So this is, again, let's see some, I'll put I think I can fit example right here. Let's say, so what I'm going to say is given, I'm going to make up two simple functions. F of x is x squared plus 3, and g of x is x minus 1. My marker's dying here. So what I'm going to do is I'm going to compose these 4 different ways. And I'm cutting this right out. Right? So in the book you see this, it means this, I'm using this. F of g make sure I leave room. G of f. And then you could make this kind of confusing. F of f. And I'm going to sneak this over here. I don't like to bounce around, but I'm obviously some limited space. So this you should have maybe underneath. G of g. Okay. So what would these look like? So again, what is this thing? This is what you get when your input into f is the function g. In this case, x minus 1. So you could, if you're comfortable, you could probably leave this step out. But I'm just being very explicit. X minus 1 is the input. So x minus 1 is the input here. I'm glad I left some room. Now this would be, is this simplified? Some people would say yes, some people would say no. Why would some people say yes? Well, this is a parabola, shifted right 1 unit, shifted up 3 units. And you get that from what you see. Now this composition isn't about the graphing so much, but that one happened to play out where you could graph it as it stands. You might want to set it to 0 and solve, in which case it'd be better if it was foiled out. This is a foil, and I'll add that 3 in as I go. So x squared minus 2x plus 1 plus 3. So it might be more useful in that form depending on what you're doing. What's considered simplified often depends on the goal. So if this was on an exam, either one is, as long as you get to there, you're good. Okay, we're going to flip it. We're going to flip-flop it. So f is what's going into the function g. So this will be g of x squared, x squared plus 3. So that's the input. That'll go there. X squared plus 3 minus 1. So I'll just combine those and be done with it. And that looks like it'll be a parabola shifted up 2. All right, now things get a little crazier. F of f. Okay. So this is f of x squared plus 3. So this function goes into itself, which is a little bit sometimes unnerving. So x squared plus 3 is squared, and then 3 is added. Now this is not one of our essential functions. if I FOIL this out, and I'll add 3 at the end, this is x to the 4 plus 6x squared plus 12. So that's a 4th degree polynomial. And that probably looks, not that this is the point, but that those things look, when you have these factors, like sort of like a W, you get sort of this kind of effect. But that's not really the point. What about g of g? So this will be g of x minus 1. So x minus 1 goes in there. So I have x minus 1 minus 1, x minus 2. Again, that's just a line, slope 1, y-intercept negative 2. My marker's dead. So the first 2 weeks is pretty light duty, right? It's, like I said, it's pre-calc, review, warm up. Next week we start limits. That starts calculus. So we're really going to ramp up next week. So bring questions for your homework Tuesday. We'll meet then.